So we're graphing, well, we're talking about in behavior on these things. So in 5.2, we're talking about graphs and what they do long term. Let me just get that one. Well, let's just think about this function here. So this is, you know that function values are really the y, aren't they? So that's really y equals negative x to the 6. Let's just call it that, you know. If we were going to graph this thing, what do you think? We did a lot of graphing last time. What do you think it might generally look like? I don't mean all the specific details. What I really mean, really more than the graph. Let me talk this way. What do you think would happen if I plugged really big numbers into it, like way off to the right, like 1, 2, 3, 4? If I go in this direction and plug bigger and bigger numbers in for x, that's the x-axis, right? So let's just do a couple. If I plugged in, I'll just make a little table down here. If I plugged in like x equals 1 to this function, it would be minus 1 to the 6th. Do you all see why I didn't put the minus in the parentheses? That's a good question. I don't know if you have that question, but that'd be a good one to have. Let's talk about it. Why? So what I'm doing right now is I'm taking this function right here, y equals negative x to the 6th, and I'm plugging in x equals 1 to it. Now remember, when we plug something into a function, we put parentheses around the number we're plugging in. So what number am I plugging in? Well, the 1. So what's going to have the parentheses? Just the 1, huh? Not the negative. Does everybody see that? That's how we know the negative is not in the parentheses. And why am I making a big deal out of that? Because that really matters as far as the sign. What's 1 to the 6th power? Well, that means 1 times 1 times 1 times 1. You know, it's just 1, huh? And then the negative in the front? Negative 1. Exactly. Now, so the answer is negative 1. What if that negative had been inside the parentheses? What if it had been like that? What would be different in the answer then? It'd be, that would now, the 6 would apply to the whole thing, the negative and the 1, be negative 1 times negative 1 times negative 1, 6 times. So what would that answer be? Positive 1, exactly, because remember, every 2 negatives make a positive, don't they? So if there was 2, 4, 6 negatives, there'd be positive 1 instead of negative 1. So that's the difference on whether that negative is in the parentheses or outside of the parentheses. Exactly, good. So on this one, the negative is outside. And how do we know it's outside again? Well, because I'm just plugging in 1. Right? I put parentheses around just what I'm plugging in. Okay, great. So now let's plug in 2. What's that going to be? Well, negative 2 to the 6th. Anybody have your calculator? What is 2 to the 6th? I actually do know it. It's 64. I might need help on the bigger ones in a minute. You can check it if you want. 2 to the 6th power is 64. And then the negative in the front, again, So it's negative 64. But what am I doing right now? I'm just taking this little equation function thing they gave me. And there I'm plugging in bigger and bigger x numbers. Why? Because right here, I'm kind of starting on the second part. I'll go back to the first part, which is a little more tricky. Listen, they're saying let x go towards infinity. Right? Let x go to the right. Now, infinity is that away, isn't it? Positive infinity. We'll do the negative infinity one, which is left, in a minute. Let me do this easier one first. Good so far? I'm just saying, what happens to the numbers I go to right now? How about if I do 3? That'll be negative 3 to the 6th. 21 something? Somebody got that one? 81, 729, 21. What is it? Is it 729? Oh yeah. I'm going too big. Yeah, you're totally right. Negative 729. Of course you are. Your calculator is telling the truth. Negative. So it's getting real negative, isn't it? It's getting big numbers but negative. In other words, if we were to think about the graph, what it's doing, it was at negative, it was right here at negative 1 at positive, and it's just going down, 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 isn't it? As we go to the right, the graph is just taking a dive, isn't it? Do you see that? As we head towards positive infinity, as we go to the right. So that's what they're saying. As x goes to positive, meaning as you go to the right, what is f of x to? Remember, f of x is y. Remember, function values are always y values, they're heights. So what they're saying is, for this function, as you go to the right, x goes to positive infinity, what's y going to do? What's the height going to do as you go to the right? Down, 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 down. So in other words, it's going to go to negative infinity. The options will be like positive infinity, negative infinity, or 0. So I just looked at it recently. So it's going to go down forever down, isn't it? As we go to the right. Does that make sense? As we go to the right, the height is going forever down. So you want to keep straight the right, left, and the up, down, because the x is the right, left, and the f of x, that's the y, that's the up, down. So as you go to the right, it's going down forever. Now, let's back up and do the one I skipped. Here, what does it mean when they say as x goes to negative infinity? What are they asking me there? Left, yeah, that's left. Because, negative infinity, the negative numbers are this way, -1, -2, -3, aren't they? So they're saying as you go to the left, what is that graph going to do? Well, now I'm going to go back to the same table we made. But I've got to plug in negative numbers, huh? I got to plug in -1, -2, -3 into the same exact function, negative x to the 6. We're kind of trying to get a feel for this function that they just made up. Negative x to the 6. And what it does way off to the right, and what it does way off to the left. So now we're doing left. We're going towards negative. X values headed towards negative infinity. So if I plug in -1, now remember, when you plug into a function, you put parentheses around the thing you're stuffing into the x slot. So I'll put parentheses around that -1, parenthesis -1, 6. But the other negative is still out there as well. Is that good? See how there's the negative that was already part of the function, and then the -1 I put in the x slot, and then the 6th power is still there as well. So the question is, that's going to be some kind of a 1. Again, it's 1 times 1 times 1 is 1. But what's the sign? Is it going to be negative or positive? Negative. How many total negatives are we talking about here? Oh, by the way, we can't just go, these two negatives cancel, so it's positive. We can't, because this is 6th power, right? Getting powers first. Remember the order of operations? I don't know if you remember PEMDAS, that. You have to do powers before you do multiplying, so we have to do the power thing. So 6 minuses here, and then one more. 7 minuses really there, aren't there? Does that make sense? Everybody see there's 7 negatives. So what does that mean in the end, negative or positive? Negative, because it's an odd amount, huh? Right? If there's 2, 4, or 6, that'd be positive, because every 2 negatives make a positive. But if you have an odd man out, an odd one, then it's negative. Yeah, so this will be -1. Very good. Now let's plug in -2. So it's going to be -2. So again, it's going to be, what was that number, 64. But is it a -64 or positive this time? How many negatives again? 7. It's always going to be 7, isn't it? Because it's going to be the 6 negatives here, which is positive, and then the 1 more negative, which makes it negative. So it's going to be -64. Plug in -3. It's going to be -720. In other words, what's it doing as we go to the left? As we go -1, -2, -3. What's the height doing? What are the y values doing? It's taking a dive, just like it did on the right side, huh? The further we go to the left, the more it's going down. So how do we answer this question? As x goes to negative infinity to the left, what's the function the y value's doing? Well, negative infinity also. And we're done with number 1. Is that good? Does that make sense how we figured that out? Plugging into that function. So what's number 2 here? Negative x. That's not a lot different. I'm going to go on to it's negative x to 7th. I didn't see it there. Yeah, so that'll be a little different. Okay, let's do that. Let me give you a second. Okay, so first off, I'll do this part. X is going to negative infinity. So that means when I make my little xy table, I'm gonna put in negative numbers like -1, -2, -3. Good so far. I'm headed to
to negative infinity. And the other side is y equals negative x to the 7. So I'm going to take that function, and I'm going to plug in like -1, -2, -3, just see where the values are going. So if I plug in -1, now remember there's the minus on the outside, and then you're putting parentheses around anything you plug in. So I get minus 1 to the 7th. So what is it? How many total negatives are we talking about here? 8, huh? Because this is 7 negatives, 7 -1, 7 negatives, and then another negative, 8 negatives. So is that positive or negative? Yeah, positive, Faith, right, exactly. So that's positive 1. And then when I plug in -2, it's just going to be some big number, but it's 128, is that what it is? It's 128. But is it a positive, so is it a positive 128 or a negative? Positive again, because how many negatives are there? 8 again. There's always going to be 8 on this side, right? Because 7 negatives, 1 more negative, 8 negatives, positive, yeah. So it's positive 128, etc. So we can tell they're all coming out positive. As x goes to negative infinity, the y values, the heights, are coming out positive. That means on a graph, as x values are going towards negative infinity, the graph is actually going up, isn't it? It's going up to positive infinity. See how these are all positive numbers? They're getting bigger and bigger. So this is positive infinity. Is that good so far? See how I determined that? Because I'm getting positive answers, aren't I? Let's head to positive infinity. And then, second part, let's do another XY table down here. This time we're going to go to positive infinity to the right. The other one was to the left, wasn't it? Now we're going to go to the right, positive 1, positive 2, positive 3, towards positive infinity on the graph. So I'm going to plug in positive 1, or just regular 1, regular 2, regular 3, etc., to the same function, y equals negative x to the 7th. So negative, and remember you put parentheses around anything you plug into the x slot. So it's negative, and then parenthesis 1 to the 7th. So is this going to come out negative or positive? Negative. How many negatives are there? Just the 1, huh? Because this 7 only applies to the, it's 1 times 1 times 1 times 1, 7 times, but only one negative, huh? The negative's not repeated, is it? Because it's not in the parentheses. That's why it matters so much. I'm making a big deal about whether the negative gets in the parentheses or not, and what exactly you put parentheses around. You're always putting parentheses around the exact x value you're plugging into the x slot. So, because that helps you be really clear what's going to be repeated and what's not. So only one negative, so it's going to come out -1. How about if we plug in the 2? Again, just the 2 in the parentheses, huh? Because now we're just plugging in positive numbers. So that's going to give me the 128 number. But is it positive or negative?
It's negative.
Because there's how many negative signs? Just one negative. So it's negative 128. So we can tell those y values are going down. So it's going down. The heights are going to negative infinity as we go to the right, aren't they? So negative, whoops, getting kind of scribbly here. Negative infinity would be that answer. And we're done with that problem. Is that making sense? We're figuring out as we go left, x negative infinity if it goes up or down, and right, positive infinity if it goes up or down. They call that the end behavior. Did they say that somewhere? Yeah, number 1. Describe the end behavior or long run behavior, like way off to the right or left. What is the graph going to do? What is the function going to do? Good. All right. Now they're giving us the picture. That's kind of nice. We don't even know what the function. There's no equation there, huh? There's no like minus x to the 7th, or they're not even telling us what the function is, but they're giving us the picture, which is super nice. So can you try that one? So first off, they say here, notice right hand end behavior. So if you're going to the right, is that x going towards positive infinity or negative infinity? positive, yeah, because positive numbers go to the right, don't they? So right here they want positive or just regular infinity is what you would put right there. Remember how to put infinity into this software thing? The letter O. Not the number. That's what I wasted time on. I was going 0, 0. It doesn't take that. Letter O, so it does infinity. Yeah. So positive infinity. And where does the f of it? Now remember, what is f of x? It's y. It's heights. So they're saying as we go right forever, here's the graph, here's the picture. As we go to the right, where does the graph's heights go? Down, down, down it goes, The heights take a big drop. All right, and then next part, left hand. So as we go to the left, what does that mean x is going towards?
Negative.
Yeah, because the negative numbers are on the left, headed forever to left, negative infinity. And as we do so, this would be negative infinity. What is the heights? What are the heights doing? Also negative infinity, Going down. Both sides go down. Good? A little bit easier than the last section so far, Especially than those crazy physics problems. Questions I can answer there? They're going to get more tricky. So now they're going to say, okay, enough with the simple functions. They're going to give us like a big complex mess, aren't they? R to the 9th minus 2r to the 8th minus r squared minus 4. And then they're going to ask, again, the same two questions. As we go, left forever or right forever, what's that function going to do? What are the heights going to do? Okay. Let's think about this. If you take something like, let me change the question for just a second and get us thinking about it. If you take x to the 8th, let's say a positive x to the 8th, and negative x to the, let's just do 4th power. In fact, those are too big. Let me make it 4 and 2. 4 power, 2 power, okay? What's going to happen? Let's say this is my function. I'm just going to make up a function real quick. Let's say that's my function. Well, you know what? I don't need it. Sorry, guys. Let me just go with the one they gave me. And I'm just going to make it x's, though. I don't like r's. I'm going to make it x's. So I'm going to take exactly what they gave me. Yeah, I'll just take what they gave me. Make it x. I like x. And now I'm going to make sure you can change that letter. It doesn't make any difference. So now think with me about what's going to happen as we plug in numbers. Let's start with the positive. The negative is always harder. Let's do the positive first off. Let's do this one first off. So as I make like an XY table, come over here so I have some room. As I make an XY table, and I plug in numbers like 1 or 2 or 3, and then that would be a lot of work, wouldn't it? I'd have to plug in, this is y equals x to the 9th minus 2x to the 8th minus x squared. Let me get this out of the way. I'll just put it right here. Minus 4. So when I plug in, it's going to be 1 to the 9th minus 2 times 1 to the 8th minus 1 to the 2nd minus 4. You good so far? I'm just plugging them. In the end, we're going to be able to do this really easy. There's a super easy way to do this. But let's start with the hard way until we arrive at a good insight. So you'd have to figure that out. I don't know what that is. 1 minus 2, negative 1. I think it's -7, I think. You can tell I don't really care a lot. It's not really important. But, okay, yeah, so we get some number. Then you could plug in 2. So, okay, I'll plug in 2 now. 2 to the 9th minus 2 times 2 to the 8th minus 2 to the 2nd minus 4. I have no idea what that is. Some number there. And you could figure, well, I guess maybe I better figure that out and quit just hemming and hawing about it. I think it's -8. -8. You can just use your calculator. It doesn't matter. Don't worry about life. If you're not able to calculate it, don't worry. In a minute, you're not going to have to calculate any of this. I'm going to show you an insight where you just write down the answer. So don't worry about pushing all the buttons. I'll do that for you. I just want you to get the main idea. So now watch what's happening. Now I'm going to plug in 3. So it'll be 3 to the 9th minus 2 times 3 to the 8th minus 3 squared minus 4. What's that? I don't know. Some big number. I'll calculate it for you real quick. 8 minus 9 minus 4. I'm getting a 6548. All of a sudden exploded. 6548. Look at that. It was like -7, -8, 6,548. Positive. Kaboom! It just exploded. What's going to happen when we go to 4 now? Now I'm going to plug in 4. It's going to be 4 to the 9th minus 2 times 4 to the 8. Whoop, 4. I'm plugging in 4 everywhere we've got x, right? And do my little calculator here. 4 to the 9th minus 2 times 4 to the 8 minus 16 minus 4. I'm getting 131,000. Positive. 131,052. Positive. What's making that happen? Again, I don't care about the numbers. You're not going to have to calculate any of those numbers. Don't worry about them at all. Just with me, think about what's making that happen. Why is it blowing up? If we did 5, it'd be in the millions probably. 6 and 7, billions, trillions, kaboom, it's just blowing up. Positive. It's going crazy positive. Why? Look at the function for a minute. Look at that function. It's right here. It's got, most of the terms are negative, right? Like that term's negative. In fact, all of them are negative except for the front term. That front term is positive, so he's positive, but the other ones are all negative. Why is it going, it started out negative, when I plugged in 1 and 2, I got -7 and -8, but then, boom, it's just blowing out positive. Why? Can you look at the numbers for a minute? What's making that, I don't mean, compute them all, but somehow this positive one is overtaking all the negative ones as I plug in bigger x values, huh? Do you see what's happening? Even though only one of the terms is positive and all the rest are negative, he's starting to win the battle. Dramatically so, isn't he? When I just plugged in 1 and 2, it was coming out negative. These negative numbers were bigger. But when I'm plugging in 3 and 4, and if you go bigger, it'll just all the more. Why? What's making the front term win, so to speak? Yeah, because he's a bigger power. That's all I'm looking for. Do you see his 9th power is a bigger power than any of the others? So as you plug in bigger numbers, the fact that he's 9 of them, right? Everybody else is just 8 of them, 2 of them, none of them. No x's at all plug in with the -4. He's just -4. But you see, if I plug in something, think about if I plug in something like 10, and eventually I would get to 10. I'm not going to do it. It'd be crazy big. But if I plugged in 10, this first term is 10 to the 9th. That means it's 10 times 10 times 10 times 10 times, 9 times. You think, well, yeah, but the next one is 10 to the 8th. Yeah, but that's 10 times smaller. Do you realize that? There's a big difference between 10 to the 8th and 10 to the 9th. It's 10 times bigger. It's got another 10. So do you see? Here's my point in all this. Whoever's the biggest term will take over eventually. He's all that matters. So all we have to do this problem is just go, who cares? And what? Yeah, don't hear me wrong. They all matter, but not in the long term. And all they're asking about here is the long run behavior. Does everybody see that? Yeah, if I wanted to graph every little nitty gritty detail along the way, yeah, everybody matters. But if all you care about is what is it going to do way off to the right, up or down, and what is it going to do way off to the left, up or down, all that's going to determine that is the most powerful term. He will win. He will take over eventually. The others don't matter. So, really then, none of this is necessary. Like I said, so I kept saying, don't worry about these calculations. We don't need to do it. So when you see a question like this, and they're asking, and the key is, I hope you're hearing me say, it's because all they want to know is in the end. The long run, way to the right and left. If they wanted to know all the details in between, yeah, then everybody matters. We got to deal with everybody. But they don't. This section is all about way off to the right, way off to the left. So for long run behavior, that's behavion, I've never heard of that, behavior, only the highest power matters. Meaning this guy right here. So really, let's just think about x to the 9th, or r to the 9th, whatever you want to call it. Nothing else is going to matter. He's going to win. He's going to win if you're plugging in bigger, because when you plug in big numbers, positive or negative, way to the right or way to the left, either way, he's going to be 9 of them, and that's going to overwhelm anybody of a smaller power, as we saw with the little table we were making. So, okay, so really it's the same as if they just asked us, y equals x to the 9th, what's it going to do as, let's do the first one, as x goes to negative infinity. So if I was to make a little table, so I'm going to totally change the question now, just make it x to the 9th, because that's all that matters. So as x goes to negative infinity, like -1, -2, -3, just x to the 9th now. I don't care about anything else because I know he's going to win in the end. What kind of values am I going to get? Remember when you plug into a function, parentheses around what you're plugging in. So -1 to the 9th. It's going to be 1. But is it positive 1 or negative 1? Because it's 9 of them, right? So it's -1. How about -2 to the 9th? It's going to be 512, I believe. But is it positive or negative? Because again, there's 9 negatives, etc. So where are we headed to? Negative infinity, huh? On that side, and then we'll do the other one. Is everybody good with that part? Now we'll do x going to positive infinity or regular infinity. And we're going to make an xy table. And we're going to do the same thing. +1, +2, positive, plugging in again to x to the 9th. So when you plug in 1 to the 9th, well, that's just +1, huh? 2 to the 9th, that's the positive 512. So where's it going? Positive infinity. There we go. So I hope you caught the main point. If they give you a bunch of stuff and all they want to know is the ends, all that matters is the most powerful term. He overwhelms the small guys in the ends, at the right and left, forever. All that matters is the most powerful term. Good. All right, so right-hand behavior. So that means as we're going this way. So if you're going to the right on the x-axis, is x going to positive infinity or negative infinity? X. Positive infinity, regular infinity, right? This is because positive numbers are on the right side of the x-axis. And where's the graph going? Up or down? Down to negative. So these numbers are going negative, because f of x is y, is heights. Remember, function values are always heights. So as we go right, it takes a dive. And now in the second part, left hand, so this is the left. So the x values go to what? Negative infinity, because we're headed to the left is the negative numbers on the x-axis. So as x goes to the left, x goes to negative infinity. What do the heights do? What does the graph heights do? Going up, and away. Like Superman there to positive infinity. The y values go to positive infinity. End behavior. Looking at what it does in the end. This is kind of some terminology. So honestly, not as important, but kind of important. We got to know the words. So find the degree. Does anybody already know what degree means? When we talk about, we're saying what's the degree of 6x to the 4th? Anybody heard that word before? What does degree mean? The highest power. Yep. Degree is highest power. Exactly right. Yeah, so what's the degree of this one? 4. Now, this is a little weird. I should say highest power on x. I should have added that part. Highest power on x, or whatever your letter is. So on the next one, find the degree of the term. Now with 5, there's no x at all there. So it's 0. That's right. It is 0, because there's no x at all there. if you want, you guys want a technical explanation? I don't know if you know, but 5 is the same as 5x to the 0 power. Does anybody know anything to the 0 power is 1? That's the same as 5 times 1, which is 5. That's why it's technically a 0 power. I'm not going to test you on that, but if you're going to go to like pre-calc and calc and stuff, then you want to know that anything to the 0 power is 1. So it's like there's really an x to the 0 power there. That's why we say the power is 0. All right, how about the next one? What's the degree of that one? Yeah, just grab the 5, huh? Easy. What's the degree of this one? 2. And now, what's the degree of that whole thing?
5.
Yeah, the biggest one, huh? 5. There it is. All right. Number 7, find the degree. So let's take that function. What's his degree?
9.
Yeah, 9, the biggest one, exactly, 9. Now, leading coefficient. Let me be clear on that. So leading, coefficient. Leading coefficient. That means, co always means with, huh? Like co-pilot is with the pilot, you know. So that means the number next to the highest power term. That's why they call it leading. He's in front of the most powerful term. So what would be the leading? So first off, what's the most powerful term in that function? That one, right? And so what's the number in front of that most powerful term? Negative 5. Is that good? Does that make sense what they mean? The leading coefficient is the number in front of the most powerful term. All right, now we're going to get into something which I've been kind of looking forward to talking over with you. I like the way this software handles this topic. Maximum number of real zeros. That's like out of nowhere. Like, what's a real zero? That's pretty much the next topic we're going to spend a fair bit of time talking about. So to answer that, let me do a little bit of introduction. So think about what we did last time with x squared graphs. Remember, we graphed them, and they're U-shapes, right? This could be like y equals, I'll make something up, 3x squared minus 2x plus 5. I'm just supposing, you know. And there's the graph, let's say, of 3x squared minus 2x plus 5. Honestly, I don't know if it really is. Don't hold me to technicalities. I just made a U-shape, basically. And x squareds are always U-shapes. And I made it going up. At least I checked on that part. It's a positive 3, it's going up. Okay. So, anyway, how many times does that U-shape hit the x-axis? Twice, huh? Twice. Here's change the color here. Here's the x-axis. This and this, you know what those are called? These are called X-Intercepts. I think you know that name. We actually have a lot of names. These things are so popular. They're also called zeros. And they're also called roots. We'll call it by all those names. So you'll want to get used to that. We call those things X-intercepts. We also call them zeros, and we also call them roots. Now, the zeros, I think, is pretty obvious. Why do we call them zeros? They're both at a height of 0, aren't they? The height of both those points is 0. So that's why we call those zeros. We call them roots because if you have an equation, they are the solutions to the equation if it's equal to 0. We'll see that a little bit later. So anyway, getting back to it. So look at this function for a second. This is x squared function. Highest power is 2, right? And how many times does it hit the x-axis? 2 times. In other words, the power tells you how many times it hits the x-axis, doesn't it? X squared hits the x-axis 2 times. So does that mean if you have x cubed, it could hit the x-axis 3 times? Absolutely. It'd be like that. Basically, the power number is the most times it can hit the x-axis. So right down here when it says maximum, so look at our function. Where's our function? It's right here. So looking at our function right here, what's his most powerful term? 9. So how many times, what's the most number of times, if we were to look at the graph, we're not going to bother, but if we were to look at the graph, what's the most number of times it could hit the x-axis? 9. It is that power. That power is the most number of times it could hit the x-axis. Now, why do I keep saying most? Let's go back and talk about that for a second. Because it could be less. Look at x squared for a second, right? We look at the x squared example I gave you, right? This x squared graph has a power of 2 and hits the x-axis 2 times. But they don't always do that, do they? Some of the ones we did last time didn't do that. I bet you can think of ones that don't do that. Let me show you. Let me make one up. Or just change the graph. So what if you have a U shape like this? Maybe that's, I don't know, 2x squared plus 3x plus 5. Just making, I don't know what that is. But anyway, there's an x squared, and how many times does he hit the x-axis? Not at all. So do you see why I'm saying at most? It doesn't have to hit 2 times. The most it'll hit is 2 times. Get the idea? So if you have some power, whatever the power is, like this one's 9, whatever the power is, that's the most times. It can't do more than that. That's the most it'll do. It may do less. So that's why they're going to keep saying most or maximum. Because it could do less, right? X squared doesn't have to hit twice, does it? It could hit not at all. See how that one doesn't hit at all? Some of them do. Some of the U-shapes are like over here, and they hit twice. Some of the U-shapes might barely nick it only once. That can happen too. So the most it can do, though, is 2, right? You couldn't make a U-shape hit more than twice, could you? That's the most it could do. So that's what we're figuring out. Does that make sense? Questions? Okay, so this graph is doing some kind of snaky business coming on down there. Do you notice how many times he hits the x-axis? Can you look close at that one? It's kind of small. How many times has he hit the x-axis? Yeah, once here, and once here. See how it hits 3 times? 3 times. So, what degree, what's the degree it could be? X to the 3rd power. They just want you to put a 3 here. Yeah, 3rd power. Now, why'd they say least? Well, it really could be higher. It could be an x to the 4th, or a 5th, or 6th, or 7th, right? Because remember, whatever your power is, that's the most you're going to hit the x-axis. You could do less. So really, that could be an x to the 4th, or 5th, or 6th, or whatever. The lowest power that thing could be is 3rd. Does that make sense? See why they're saying least? The least, the lowest. It couldn't be x squared, could it? It can't be lower than 3. That could not be an x squared graph, could it? Because x squared graph could only hit at most 2 times. And we already know that thing's hitting 3 times. Am I making any sense? It couldn't be x squared, could it? Because x squared would only hit twice at most. It could be x cubed or higher. So the lowest it could be is x to the 3rd. So they want you to say 3 here. The least possible degree. It's got to be 3 or more because it's hitting 3 times. All right, now we're going to change the game a little bit. See how that graph on number 9, do you see where the x-axis is on that one? It's way down here. It's really, I guess it's only hitting the x-axis 1 time, huh? It's pretty far away from the x-axis. That graph's all way up, isn't it? So there's a second way that we can figure out the degree. There's 2 ways. One of them is how many times it hits the x-axis. The other way is turning points. When the graph goes from going, like right here, it's going up, and then it goes down, like on a roller coaster or something. That's called a turning point right there. I'll say TP, turning point. Or right here, goes from down to up. That's another turning point. So basically a maximum or a minimum. And then here it does it again, right? Turning point right here. TP, right at that little one. And then right here again. Right there. Another turning point. It was going down and it goes up. Right? Everybody see it right here? Turning point right here. Turning point. So this one has 4 turning points, doesn't it? You see that? Where it's going up and then down. And then, it just keeps, where it turns the direction it's going. So this one has 4 turning points. Well, what do you think that means about the degree? You know what I would do if I was in the, rather than just tell you the answer, here's the rule, and da-da-da, and I will in a minute, I'll certainly write out the rule for you. But you ever heard the old saying, you do somebody more good, rather than if you hand them a fish, you teach them to fish, right? Because then they get their own fish. So I'll give you the rule and everything, but I would do you a lot more good if I could continue to show you how a math science person thinks so you can get your own. Because you know what, who can remember everything perfectly? You could be in the middle of the exam and go, oh, I forgot to put it on my card. What's that rule with turning points? And because there'll be something like this on the test. I was just making it this morning. I put some of these, I know these are on the test. So, and you're like, I don't remember. You know what you could do? You could fish and get your own fish. How? How does a math science person look at something like this and come up? Here's what they do. They just take what they know. You don't have to know everything in the world. They just take the most simple example they know, x squared. Because we know a lot about x squared, right? And they go, I don't know. What if I have an x squared graph like that? And they know it's a U-shape, right? Just take what you know. You know an x squared graph is a U-shape, right? How many turning points does that have? How many turning points there? Just one, just right there. There's his TP, right? He goes from down to up. He just has one turning point. So one turning point, and what's the degree? 2. So for degree 2, one turning point. We know that one for sure, right? That's just the simple case. We know all about it. A U shape, degree 2, x squared, turning point 1. So now do you see it? What's the connection between degree and turning points? Are they equal?
No, but would that be one turning point and it's 2 degrees?
Yeah, this is one higher, huh? See that? And that's the answer. So therefore, if you have one turning point, you have degree 2. If you have 2, 3, 4, etc. So we have how many turning points up there? 4 turning points over here. So if you have 4 turning points, this one has 4 turning. Then what must the degree be? 5. Just one more. Yeah, we're not doubling. Yeah, it could have been doubling, huh? You think maybe it's doubling. No, it's actually just adding 1. It's just adding 1. So the degree is 5. Does that make sense? So we have 2 different, so we see this. So what is the least possible degree? Degree 5. So basically, let me write out the 2 rules for you now. But I'd much rather, because who can memorize everything perfectly? This is how to get your own fish, so to speak. Is when you're stuck in the middle of a math test and you can't remember, just think back to what you know and follow the pattern. You know what math is? In the end, math is patterns. All of math and science is patterns. I don't know if that's ever occurred to you. It's getting better and better with patterns. So here is the rule. The degree equals the turning points, the number of turning points plus 1. Or the degree is exactly equal to the number of times it hits the x-axis. Or those are called zeros, huh? So there we go. We've had 2 rules then. And that's it. That's all the rules there are. So either the degree is the number of turning points plus 1, or it's the number of times it hits the x-axis. So, all right. So come on down then to, so that's it for number 9. So copy that rule down. With that in mind, let's look at number 10. Now, number 10, they're going to bring in a new word. It's going to be easy. It's going to be easy for you. Oh, except for one just part at the end. So basically, they're going to say, okay, a polynomial of degree 3 has a root of multiplicity 2 at x equals 2 and a root of multiplicity 1 at x equals negative 1. Now, that sounds awful fancy. What are they talking about? Well, basically, here's how it works. When they give you a root, remember root is another name for a 0. So root, 0, X-intercept, all the same thing. And what you do when they give you roots, you go x, and then you go opposite of the root, and then x, opposite of the root, etc. So it's parentheses, and it's going to be y equals, there's going to be some number in the front, call it a. Remember how we did some of that last time, where you have to find the number in the front, call it a? So we have some number in the front, a, and then x, opposite of the root, x, opposite of the root. And so what are those numbers? So, and then the power. There's going to be a power here and a power here. And the power is the multiplicity. Multiplicity. So let's do it. So first off, they say a root of multiplicity 2 at x equals 2. So I take the x equals positive 2, and I'm going to put negative 2 in the parenthesis. Is that making sense so far? The opposite. If they'd said negative 2, I would have put positive 2. And then the multiplicity, that's the power that goes on that parenthesis. Because that means how many times it's multiplied. That's what the word multiplicity means, right? That's what a 2 power means, right? You guys know that. Anything to the second power, that means there's really 2 of those, aren't there? It's multiplied twice, right? You with me on that? And then the next one, I can erase some of this stuff that's in the way here. The next one says it's a root at x equals negative 1, so that'll be what in the parentheses? Plus 1, it's always opposite. So it's always opposite, whatever they say for x. And the multiplicity, so don't confuse the multiplicity with the root itself. The root is x equals negative 1. So that's what goes next to x. Whatever x equals goes next to x. X equals negative 1, opposite, plus 1 goes next to x. And then multiplicity 1, that means there's a first power out here. And you don't even need to show a first power, right? That's just understood to be there. So it's not needed. So far, so good. So in other words, what we know now, if I can come up here and use this space, what we know now is that we have y equals a, x minus 2 squared, x plus 1 to the first power. We got to find the a, though. But are we good so far? Does that make sense? We just take the opposite of the x in the parentheses, and the multiplicities are the powers, because that's how many times it's multiplied. Now, the only thing we have left to do is we got to find the a. So step 1 is to write the opposites and the powers for the multiplicity. And step 2 is to do what? Well, they're saying, notice what they're saying here. The y-intercept is negative 2. Yeah, so that means, now what's a y-intercept? Remember what we've learned about intercepts? If I was to do a graph, this is the y-axis, this is the x-axis. That means down here at negative 2, there's a point, right? There's some kind of graph, I don't know, blah, 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 whatever. But I know it goes through the point negative 2, huh? That's what they're telling me when they say it has a y-intercept of negative 2. I know it crosses the y-axis at negative 2. What's the coordinates of that point? That's not, remember, 2 numbers make a dot, not just 1 number. There's more than just the negative 2 there, huh? What are the 2 numbers? 0, negative 2. Beautiful. It's over 0, down 2, isn't it? So remember, whenever you have an intercept, the other number is 0, isn't it? Y-intercept or X-intercept means the other number is 0. So that means that's the point 0, negative 2. When they tell me y-intercept negative 2, they're really telling me 0, they're telling me x is 0, y is negative 2. They're telling me those two go together. So that means I can go up here to the equation and plug in x is 0 and y is negative 2. So plug in x is 0, so I'll just say plug in 0, negative 2, x and y, and plug in negative 2 for y. See what I just did? So then we'll have negative 2 equals a times 0 minus 2 squared times 0 plus 1 to the first. And I'm going to be able to solve that equation for a. Everybody see what I did? So I took our original equation that's up here that we got by putting the opposite of the numbers next to x and the powers in as multiplicity. And then I plugged in the y-intercept. They're always going to do it this way. They'll give you the y-intercept. They're going to do a lot of this in the rest of this section and the next one. And I just made the exam this morning, and there's 2 or 3 of these on the exam where you got to do the y-intercept thing. So make sure you know how to do that. So you've got to plug in 0 for x and y is named 2. You can definitely do this. Just takes a little practice. So plug in that x is 0. And now, so then we have this little equation. Minus 2 equals a. And now what is, this one is minus 2 squared. This one is 1 to the first. So what's minus 2 squared? Positive 4 times 1. So I'm kind of running out of room here. This means, bring it over here, negative 2 is a times 4, huh? Put that in a little bit better. Are we good? Because 4 times 1 is just 4. How do you finish getting a alone? We're trying to solve for a. How do we finish getting a alone? Divide, because that 4 is multiplied by a, so the opposite of multiplying is divide. Divide by 4. So a must be minus 2/4, but we reduce all fractions. So what is that as a reduced fraction? So it's negative 1/2. Yeah, a is negative 1/2. So what's our function then? We're done. It's negative 1/2, the a in the front. A is always the coefficient in the front, right? Negative 1/2. X minus 2 squared, x plus 1 to the first power. There it is. There's our function. Okay, so here's number 11. So I'll do the beginning part. We write y equals a, and then we do x, and what do we put next to x? The opposite of the x values, huh? So if they have x equals 2, what am I going to put next to the x? Negative 2. And what power is going to go on that one? 2, because of the multiplicity. And the next one, x is negative 5. So what's going to go next to x? Positive 5. And the power, the multiplicity? 1. Is that good for the steps? That's step 1. Just x opposite, and the powers are the multiplicities, like that. And now, step 2, plug in the y-intercept. So that means y is negative 37.5 is going to go right there, and x equals 0. Up. Thank you. My eye went to the other one. So this should be 5. So that means this one is actually what? Negative 5? And the other one's positive 5. Did I get the y thing right? Yeah, that is the right y thing, huh? Good. Thank you. All right, yeah, so it should have been 5. So it comes out negative 5 and positive 5. All right, now take it from there. Now plug in y equals negative 37.5 over here. And plug in x is 0. Remember, because a y-intercept means the other letter is 0. X is 0. That's what a y-intercept point is. So plug in 0. Like that. So, yeah, so we just plug in, and then we use our calculator. So negative 37.5 is a. This will end up being 25, right, because it's negative 5 squared. This will end up just being 5. So that is 125, and then so to solve for a, we divide by 125, and so, was it negative 0.3, right? Yeah. Negative 0.3, so that's a. So then what's our final answer then, the final function? Y equals, I'm going to run out of room here, y equals negative 0.3, x minus 5 squared, x plus 5. There we go. Yeah, so what have we just been saying about intercepts? What do we know about intercept points? The other letter is 0. Right? Remember, think about if you have any kind of graph, blah, 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 whatever. Here is a y, it's a y-axis. This is the x-axis. Think about, like, if maybe that's up 7, that's over 3 or whatever. That really means it's over 0 up 7, huh? And that means this one's over 3 up 0. The other numbers are like, this is the x and the y. This is the x and the y, right? See how at a y-intercept right here, at a y-intercept, the x is 0, the other letter is 0, and at a x-intercept, the y is 0. So do you see how at an intercept point, the other letter is 0? So at an x-intercept, y is 0. At a y-intercept, x is 0. It's just the very nature of what it means to be an intercept. If you're on the grid lines, one of your numbers is 0, huh? If you're an intercept point, you're on the grid line, one of your numbers is 0. So whenever they ask us to find a Y-intercept, what do we know right away? X must be 0. The other letter, right? Other letter equals 0. So at a Y-intercept, X is 0. And then in a minute, they're going to ask us for the X-intercept. We'll make Y 0. So that means I take this equation they're giving me up here, and I say, okay, I'm going to plug in X is 0 right there and right there. Is that good? And by the way, P of X in the front, that's really Y, isn't it? Remember function letters, F of X, G of X, P of X, that's just Y. So it's going to be Y equals 0 minus 2 squared times 0 minus 4. See how I plugged in 0 for X? Because that's what a Y-intercept means. X is 0. So we get Y equals minus 2 squared times minus 4. What's that? 4 times minus 4, negative 16. So that's the, so I think really they want both coordinates. In other words, they want you to say 0 minus 16. Remember, because again, the X was 0 that led to that Y value being negative 16. So I guess they just want the minus 16 on this one. Okay, and then the next question is going to ask us for the X-intercept. So that's all part 1. Now part 2 is going to say, find the X-intercepts. Okay, so remember what an intercept means? At an X-intercept, what's going to be 0? Y is going to be 0. Other letter equals 0. Yeah, so at a Y-intercept, X is 0, at an X-intercept, Y is 0. So the other letter is 0. So that means Y. So I'm going to take this equation, which is Y equals X minus 2 squared times X minus 4. Let me do that a little bit better. X minus 2 squared times X minus 4. And I'm going to plug in Y as 0. Right? So I'm going to put 0 right here in the front. Are we good to there so far? Now, so I'm trying to solve that equation now, right? I plugged in Y is 0 on the left side, and I'm looking and saying, hey, what could X be? What could I plug in here to make it equal 0? What could you plug in to that first X spot right here to make it 0? What minus 2 is 0? Well, 2 minus 2 is 0. Yeah. And what could you plug into this one? What minus 4 is 0?
4.
Well, 4. So in other words, the answers have to be 2 and 4. We can tell just by looking. We don't have to do anything fancy. That's why we like the parenthesis form. Because when it's factored, that's called factored form. When there's parentheses, you can just look at it and go, well, it's got to be 2. 2 minus 2 is 0. Because they're multiplied, right? Remember, if you make either one of them 0, since they're times, 0 times anything, the whole thing will be 0. If you make either one 0, the whole thing is 0, isn't it? So 2 or 4 are the X-intercept points. Those must be the X-intercepts. We good to there? Now they're going to ask us, what happens as X goes to infinity? They're saying as X goes to infinity, Y is going to head to what? This is Y out here, of course, right? So they're saying as X goes to infinity, what's Y going to do? What's going to happen to that function as X goes to infinity? Well, let's think about it. So we want to take this function here, and we want to think about plugging in bigger and bigger X values to it. You tracking with me? X is going to infinity. So we want to think, okay, what if I plug in a bigger and bigger and bigger X value? What's going to happen? Like, what if I plug in like 10? What am I going to get? I'm going to get 10 minus 2 squared times 10 minus 4, which is 8 squared times 6, huh? Right? So that's, what is that? I don't know, but it's some big positive number. That's all I care about. It's some big positive number. What if I plug in, that's what I would suggest. Just think about plugging in a really big positive, maybe even 100 would be better. Just think, because that's what you're trying to decide. As X heads towards infinity, so let's put in 100, because that's a little bigger. It's the same result, but be more clear, I think. So as you plug in something really big like 100, way off, you understand what I'm doing? I'm thinking about way off to the right, 1, 2, 3, all the way to 100, right? I'm thinking about way off towards positive infinity. 100 is a big number. What are we going to get there? Well, that would be 98 squared times 96. What is that? Basically positive infinity. It's not really infinity, but you know what I mean. It's getting bigger and bigger and bigger, right? At 100, it's already a big positive. If you plug in 1,000, 1,000,000, if you go further and further, way over here is 1,000, and as you go further and further to the right on the x-axis, the y value, y, is going to equal positive infinity, isn't it? Is that making sense? Now, they're going to ask, as x goes to negative infinity. So I would suggest you plug in negative 100. Let's go down here and say, as x heads to negative infinity, y equals, so y is, again, the x minus 2 squared times x minus 4. Let's plug in negative 100. So for negative infinity, I'm just going to use negative 100. It's just a big negative number. So negative 100 minus 2 squared, negative 100 minus 4. What do we get? Negative 102 squared times negative 104. Now, it's some big old number. I don't really care what the number is, but you know what I do care? Is it positive or is it negative? And for that, we just count the negative signs, huh? Just count the negative signs. How many negative signs are we talking about here? 2 negatives there and 1 more negative. It's going to be negative, yeah. 3 negatives, it's going to be negative infinity. It's going to be some giant number and negative, isn't it? Do you see how y is headed towards negative infinity? Does that make sense? So as you plug in a really... So when they ask you to think about x going to positive infinity or negative, just plug in positive 100 or negative 100 and find out if you get a positive answer or a negative answer. And that'll answer that question for you. Question number 13, find a degree 3 polynomial that has zeros, negative 6, 2, and 7, and the coefficient of x cubed is 1. So let's give it a try. How do we do that? So remember what zeros are? Remember how we handle this? These are the kind where we go y equals x, and we go opposite of the 0 or the root. Same thing. Remember, a 0 and a root are the same thing. So we're going to go x opposite of the 0, x opposite of the 0, and x opposite of the 0. So we just grab the 3 zeros, which is the same thing as roots. They're all the same thing. They go in parentheses with the x. And so negative 6, what am I going to put in the first parenthesis? Plus 6. Next one, plus 2. What's going to go in the parenthesis? Minus 2. And the third one, 7. Minus 7. Now, the coefficient, 1. That goes right in front. Remember, coefficient means the number in front of the most powerful term. That just goes right in the front. And we're done. That's all there is to that problem. It's just all about knowing that zeros or roots go in parentheses next to x opposite. Like that. So they give us a function f of x. minus 2x to the 9th plus x to the 7th minus 4x cubed minus 3. As x heads towards negative infinity, what's the function going to do? Yeah, I only need this term. Remember, because he's more powerful. Only the highest degree, only the highest degree term matters. So only the one that's highest power matters. The other ones don't matter, just the one that's highest power. Because as you plug in big numbers, he's going to dominate. He's going to take over. So, okay, so then what are we going to do? I suggest again, let's just go back to this plug in 100 or negative 100 stuff. That'll work great, because that's like going, way off to the right or way off to the left. So this part, they're asking me to go to negative infinity. So what am I going to plug in? Positive 100 or negative 100? Negative 100, is this making sense? I'm going to plug in x is negative 100, because that's like headed towards negative infinity. So plug that in. What are we going to get? We're going to get minus 2 times negative 100. So y will equal, remember, f of x is y. Y will equal negative 2 times negative 100 to the 9th. And really, I don't care what that number is. Some gigantic number, whatever. It's billions and trillions and stuff. But is it negative or is it positive? How many negative signs are there?
There's 11.
I'm counting. So this is 9 negative signs and 1 more negative sign. 10 negative signs, right? Is that making sense? Because that 9, right, will repeat that negative 100 9 times. 9 negative signs and 1 more negative sign. 10 negative signs. So is it positive or negative in the end? Positive infinity. It's going to be a gigantic number. Positive infinity, huh? So as x heads towards negative infinity, like negative 100, y is going to head towards positive infinity for this function, isn't it? All right. And then they want you to do the follow-up, same thing, as x heads towards regular infinity. Can you do that real quick? I take the same function. Super, super big, but is it negative or positive? How many negative signs do we have? Only one. So it's negative infinity, isn't it? Okay, so they're giving us this question. There's the function, x plus 1 squared times x minus 9. And they want us to find the y-intercept. So we get in the hang of intercepts. How do we find a y-intercept? We set x equals 0, right? It's always opposite letter of 0, because that's what an intercept means. Remember, if your graph hits the y-axis at a y-intercept point, right, that's the y-axis, that means it's over 0 up some number, isn't it? It's x is 0, right? That's what a y-intercept means. The x value is 0. So we set x to 0. So we take that equation. Remember, this is y in the front. So this is y equals, we plug in the 0, like that. And we just get, what's that going to be? 1 squared times minus 9. That's just minus 9, huh? So the y-intercept must be negative 9? Getting the hang of those intercept points? That's a y. Now, what do we know? Now, let me pretend this goes on like this. Here's an x-intercept. What do we know at an x-intercept point? It's over some number up 0. It's y is 0, isn't it? So again, I'm just reminding you that it intercepts the other number is 0, or the other letter, I mean, is 0. The other letter is 0, right? Because if you're on the grid line, one of your numbers has got to be 0. That's why you're on the grid line. So at a y-intercept, we make x 0. Therefore, at an x-intercept, we set y to 0. So we got to make y 0. So we take that function, what function? The original function, and we make y 0. Where's y? Where's y, Daniel? Right there on the left, right? Y is on the left side. We good? Is that making sense? 0 over there on the left side. We good? So we make y 0. We make that left side 0. When we have that function, we make y 0. Now, what x values, what could we plug in for x there to make this first part 0? What can x be? -1, huh? Yeah, because -1 plus 1 would be 0, right? And what could we plug into that x to make this part 0? 9. So those are the answers. -1 and 9. You can tell either one of those will make it 0, won't they? Because if you make any part of that 0, they're times together. So 0 times anything is 0. That's it. Those are the two X-intercepts. Are we good there? Is that making sense for that? Questions I can... by 5 card. At a Y-intercept, make X 0. At an X-intercept, make Y 0. Okay, now last part of the question. Number 15, again, let me rewrite it here. P of x equals x plus 1 squared times x minus 9. And they're asking, as x goes to infinity, what is y going to go towards? So let's try that again. So what do we do with these x going to infinity things? What do we plug in? Yeah, positive 100 or negative 100. In this case, it's positive infinity. So plug in positive 100. And just find out if the answer comes out positive or negative, because that's where it's going. And then after you finish that part, come down and do the same thing for as x goes to negative infinity. Plug in negative 100. So as we plug in positive 100, we get 100 plus 1 squared times 100 minus 9. So does that come out positive? This is 101 squared. Y will equal 101 squared times, what is that, 91? Is that coming out positive or negative? Positive. Yeah, everything's positive there. It's positive infinity, huh? All right, and then the next one, plugging in, what are we plugging in? Negative 100. So we can do that one. So we plug in negative 100 plus 1 squared times negative 100 minus 9. What are we going to get? Is that negative 99 squared times negative 109? How many negatives do we have there all together? Is everybody right? Does everybody see we have 3 negatives? So it's 2 negatives and 1 more negative, 3 negatives. And 3 negatives, is that negative or positive? Negative. So it's negative infinity, isn't it?